Now I'm going to move on to part 2, biological differences between fatigue and PEM. So biology is important, right? If we can identify differences between these two symptoms, it may give us some hints about how to manage them. What I'm going to give now is a brief summary of very important research by Professor Robert Woest and colleagues from Amsterdam. In March 2024, I created a short information video summarizing their paper from January of that year. You can watch this video on my video tips of the month page by scrolling down to March 2024. On that page, all the videos are in reverse chronological order, with the most recent being at the top. So in this video, I'm not going to repeat everything I already said. I'm going to give a short summary of the most important findings. They did so many things cleverly in their research study, and the first one is who they studied. So it was a small study because they did a lot of intensive investigations. There were 25 people with post-COVID, all of whom screened positive for post-exertional malaise. And there were 21 age and sex matched healthy controls, people who had had COVID and had fully recovered. Now, the long COVID group was not bedridden. They would probably fit more into the moderate or moderate to severe range of illness. They had an average step count of 4,000 steps per day. The goal of the study was to try to identify and differentiate whether the biology of fatigue is different or the same as the biology of PEM. So fatigue is baseline energy, meaning before you exert yourself, how are you feeling and what are your biological parameters? They assessed fatigue by analyzing muscle cell structure and function before exertion. They measured post-exertional malaise by noting whether after exercise any new abnormalities had developed and whether these abnormalities differed between the two groups, the people with PEM due to long COVID and the people who had had COVID but had fully recovered. So the really important conclusion from this study is that fatigue and PEM are not the same. Before exercise, the participants with long COVID showed abnormalities in muscle structure, mitochondrial function, and immune function. This provides objective evidence of fatigue in people with long COVID. In the long COVID group, as compared to the controls, there was an increase in glycolytic or anaerobic metabolism and a change in muscle fiber ratios. What this means is that there was more quick to fatigue muscle fibers, and they were relying more on glycolysis, which produces less energy than oxidative metabolism. During exercise, the subjects with long COVID couldn't exercise as much. Their VO2 max and peak power were lower, and they moved less air in and out of their lungs, and their muscle extracted less oxygen from that air. So this is all evidence of fatigue and a lower capacity to function and to do activities. So what about PEM? This was measured by seeing what happened after the exercise bout. They found evidence that in the PEM long COVID group, the mitochondria were making even less energy after exercise than before. So the mitochondria had shut down, and this may be an objective marker of PEM. They found evidence that the muscle cells, which normally get damaged in exercise, that's perfectly normal, had more damage than usual and more damage than the control group. And this was in part evidenced by the repair mechanisms were functioning on high gear. Really interesting, there was an accumulation of a misfolded protein called amyloid. There was some amyloid in both groups after exercise, But in the long COVID group, there was a lot more than in the control group. When there's a lot of amyloid in the cells, it basically gunks up all the mechanisms and prevents the cell from working as it should. Now, in addition to this, they wanted to look for evidence of two common theories of what causes long COVID. One of the theories is that there is persistence of the spike protein and or viruses in the bodies of people with long COVID. And this has been shown in other research studies, but in this study, there was no evidence of viral persistence, at least in the muscle cells, which is what they looked at. Another popular theory is that the fatigue in long COVID, and possibly in ME as well, is caused by decreased blood flow to the tissues as a result of microclots, so tiny, tiny fibrin clots in the littlest blood vessels that basically block them. Now, again, this has been found by other researchers, but was not found in the WOOS study. So in conclusion, the research about fatigue and PEM by this one group shows that both fatigue and post-exertional malaise are pathological conditions, meaning they're associated with things that have gone wrong that are objectively measurable. Some abnormalities are found at baseline. This would correlate with fatigue, and some abnormalities came on or worsened after exertion. These would correlate with PEM. So the bottom line is that if you have long COVID or ME, if you experience fatigue or PEM, your symptoms are not in your head, they're at least in part in your muscles.